developing smart contract from scratch with Line blockchain. And I am Takahashi from block engineering team. I am developing the VM of the Line blockchain and also doing the research. Thank you. The agenda for this session is as follows. Chapter 1, the road to smart contract. And this is a story up to the introduction of smart contract. It may sound abstract, but have you heard of keywords such as NFT and Web3 as keywords surrounding technology that have become hot topics in recent years? I'm sure all engineers have heard of them at least once, even if you are not an expert in this field. These words are becoming increasingly popular, not only in the industry, but also in the general public. And Line is also developing various business throughout the group, including the NFT comprehensive marketplace. One of the technologies behind the NFT and Web3 is blockchain. As of 2022, many developers and companies are working hard to develop, lease, and popularize blockchain services, aiming for the first paradigm shift since the internet. And there are so many services coming out of blockchain, and in order to develop services using blockchain, what sort of issues do you face? First, a typical blockchain-based application requires payment of so-called gas fees in order to use the services. This gas fee is usually paid using cryptocurrency. So the user needs to acquire cryptocurrency before starting to use the service. You will then need to install a wallet to manage your cryptocurrency. Unlike previous services that could be easily used with social login such as Line, blockchain-based services need to use services through some complicated processes, and therefore this is a result in a hard time of attracting users, even though trying to acquire and develop proprietary technology for blockchain and developing services. Line blockchain enables users to reach 1 million wallet without any special preparation by users. We have prepared a unique wallet called Line Bitmax Wallet as a gateway to user service. This makes it easy for users to start using the service without having to prepare. You now have an environment that makes it easy for people to use the blockchain and reach 1 million people, but if it is so costly to make the service available, it makes no sense. So for the developers, we have the Line block developers, Line, and the service called Line blockchain developers, and you don't need to acquire any special skills, and the tokens used for applications can be easily issued. And now I can easily develop application using blockchain. And also the application developed can widely be accessible to many users. And using blockchain, I have solved all the issues for developing applications with blockchain. However, in reality, there are so many issues to be solved. One is a Line blockchain developers' functions are limited. At present, the issues of tokens for services and also the transaction, these basic functions are available. In other words, using the token, what do you do? Escrow or auction? The application-specific logic does not exist on blockchain. Although it is possible to issue tokens easily, Although you might want to naturally implement application-specific logic on the blockchain, this is not easy. To solve this issue, we will be releasing a smart contract feature on the Line blockchain. This allows developers to execute the business logic of the services on-chain. Because smart contract uses proprietary language and technology to develop it, it tends to have a learning cost, including the need to start by learning the language. Therefore, we adopted WebAssembly to ordinary programming language to develop smart contract that is called CosmWasm, which is an execution platform for building smart contract. CosmWasm uses Rust smart contract development method, and that is compiled to WASM file to deploy it on blockchain. I am not going to discuss the details of CosmWasm here, but there is another session on how to find bugs in CosmWasm smart contract. Please have a look if you are interested in this. By releasing the smart contract feature, application development changes this way. Currently, only token issues and remittance are executed on-chain via LVDA. Application-specific business logic does not exist on-chain, so it is necessary to add such functionality through normal web application development and link it to token. On the other hand, with smart contract, not only token issuance but also business logic can be implemented on-chain. Therefore, all functions required for the services can be completed on-chain. This way, you can create a more blockchain-like application using Rust, although you may not be used to it. Or maybe you have used Rust, but you are not used to smart contract development, and you might wondering how to develop the smart contract. And developers using Line blockchain, we would like to talk about the tutorial on NFT contract, how to use smart contract. And after the session, there's a GitHub repository. Please refer to it to make your own contract. Now I'd like to begin the smart contract development. The first thing you need to do is to create a project template using the template provided by CosmWasm. Cargo generate command is used to prepare a repository for developing contracts easily. Now, I will explain what you should implement using the prepared files in this service. msg.ls, and to do what you want to do on a smart contract, define as a message. And the CosmWasm smart contract allows following the defined messaging to execute the processes. The basic messages that you need to define are the following three. First, instantiate. And in order to initiate smart contract, this is a message that is executed. Second, execute. After initialization, in order to send transaction to the contract, the message is used. Last but not least, query. The state, to get the state of being stored using smart contract. This is a message to allow get data. And using the three messages, be able to deal with contracts. Today, using these three, having conversation of contract, please remember. And I'd like to specifically look at the examples of these messages. The first instantiate message will be like this, for instance. It is called when a smart contract is initiated, typically setting the name or symbol of the token. The message of execute enumerate the transaction to be executed by enum. For instance, if you want to perform a transfer of a token, the recipient and token ID are set as parameters to receive the token. I define the same for query for execute. To check the balance of a specific address or the owners of a token, define query. That's all I have to say about message. Next, let's look at state.ls. State.ls, the information that you want to store with smart contract is defined as structure. For instance, the token structure is defined as such. And also the token defined, the structure of the token defined is stored in the store.ls storage. Let's implement the storage. And the storage that is accessible or defined in the package, please refer to the details. Now it's time to process messages with contract at .ls. And depending on message, instantiate, execute, and query, these are three functions that needs to be implemented. Instantiate is to instantiate the contracts. In this contract, the instantiation receives a message of the names, and if there is no problem with the format, then store them into the storage. Let's look at a line-by-line code. And the three functions that I am going to explain are from macro, from entry points. There are four the depth smart to access the other contracts and also to introduce other contracts. And these are four arguments, and their API object that has a utility functions. And depth MUT to update the state, and the ordinary depth is read-only. So these are the differences. And env object at the execution about the state of the blockchain, and also the contract information at the execution. And message info object for calling contract, and also to sign the transaction and send messages to the address, and also the fund remitted with the message included. Finally, about the return value, and all the entry points are through the results. And if it is successful with the COSM-WASM, response defined in the COSM-WASM is returned successfully. And there's a difference message, messages, sub-messages, message, attributes, and data. These four are included. And sub-messages and messages, other contracts and other chain native messages are called to add to responses and attributes in order to output event logs. And if the contract execution fails, in most cases, error.ls defines the contract errors, and the contract errors are returned generally. And within the function, the description, at last, the responses are all the default from the fields that are ready as well. But if you want to return any value, use add attributes to add to response. Next, execute. Even I say execute, the way we write execute is almost same as instantiate.
So let's start from the entry point. Different from the instantiate is different from the instantiation. It's defined on the enum. So in the match sentence, make sure to branch each logic to write code. And also, for example, in this transfer, we set the contract executed account as a sender address. Therefore, as I explained, we obtain the address executing the contract from the sender of the message info and pass it on to. The logic is implemented within the function called where you branched. I would recommend to you that the response, the message name, is kept as action in its attribute. Set the value in the message so that you can check them in the event log later. So here is the query as the last part. Different from the instantiate or execute, as in the parameter, there are three parameter steps, M's in query MSG. There will be no update on the query, so the depths, that read-only depths is used instead of the depths MUT, and as a return value, only the binary object will be returned. And the implementation, many of the cases are very simple, and the data that you would like to snatch is actually in the storage available, and you read it and then return it as a binary object. This is actually the standard flow, but there is another thing that I would like to share with you so that you can expand the capability of yourself for the development, which is the submessage and reply. By using these, you can call another contract and you can obtain the result of the execution within the contract. The structure of the submessage and the reply is defined as shown on the screen. In a submessage, ID specific to each message, and also the message that you want to send, and the guess limit in a contract on a response callback needs to be defined. And the reply on, which is the timing for the called up, error, and success, and never. These are actually three defined, the callback. So when we actually use this submessage in the reply, for example, when you initialize a contract, and at the same time, if you wish to initialize another contract, and if you want to obtain that contract address, and that's the time when you use the submessages in the reply, you set the response, the message response of the was message, and instance reply ID needs to be defined as a unique one when you use it as a callback. So callback is processed by using the entry point. Once that call is successful, and then handle instantiate reply, which is a parameter, and the response should be given back to it. And actually, if you want to initialize the contract to obtain the address, you implement handle instantiate reply as shown on the screen. Check the events of the response and obtain the contract address on the event, and then the NFT contract address to be set in the data called auction configuration and store it. This was using a contract development basic flow. It's just I walked you through. And there is another way to call the contract by using the submessage in the reply. It might sound like very complicated for you, for those like who are familiar with the other platform. So there is another way to call the contract by using the dynamic link, and I will show you how to use it. A separate session titled Dynamic Link Smart Contract Interaction and Method Developed by Line gives you more details on dynamic link architecture if you're interested in. So for example, from the contract with the business logic, and if you wish to NFT contract, transfer, and approve, what we should do. So on the callee side, where the function that you would like to call is implemented, use the newly added macro and then define the function. That's all you have to do. An initial caller contract, you have to actually prepare two things in order to call the callable point designated functions. First of all, you have to use on a contract trait and then define the structure to call the contract address on the caller side. And then dynamic link macro to be used to define the function that you would like to call. And predefined NFT contract is defined and transfer from and approve, or they actually is the function that you would like to call. So now you're ready to call another contract by using the dynamic link. All you have to do is to define an NFT contract, initialize the structure, and call the function. Different from the message format, it's very simple to call the contract. If you're going to develop a Line blockchain smart contract, I would like to encourage you to give it a try to this feature. Thank you so much to bear with me. So this comes to the end of the basic guideline of the smart contract development. Let's deploy what we just created as a contract and execute it. This is actually overall a flow using a Cosmos WASM smart contract execution. And first, you compile the code on the WASM file, and then you upload into the chain by using a store common. And the code ID will be created to the WASM file that you uploaded. But at this point, contract address is not allocated. So for the store file code ID, you initialize instant comment, so that would prompt the creation and generation of a contract address, and then for the instantiated contract, you would use the contract by executing the execute or query. Different from the other platforms, deploy process is not just one choice, but they're actually store and instantiate in a process flow. So that even if it's the same code ID, every time you instantiate, a different contract address will be populated, will be regarded as a different contract. So in this time, we developed the contract on the assumption that the NFT would be on the auction. NFT and auction contract exist separately, and the seller first populate NFT. And then by using the auction contract, we'll put it out for the auction, and then the buyers will do the bidding. Lastly, based on the result of the auction, we will actually extract the token and withdraw the token. Let's look at the entire flow of the creation of the contract. By the way, I've already pushed the contract that I created by using my own GitHub. If you're interested in, you can take a look there. So already the Sim app chains activated. Check-in account. We can make sure that there are two accounts called Alice and Bob. So in this case, we're going to use these two accounts. Alice will populate NFT and put up for the auction, and Bob will try to do the bidding. So first of all, we'll do the compiling of the contract. We could do the cargo build command, but in this case, the Cosmos wasn't Rust optimized. That's the one that we're going to use as a tool. When the compile is completed, under the artifacts directory nft.wasm and auction.wasm, you can actually see the two WASM files are created. First of all, in order to create NFT, we store the NFT WASM in a chain using the store command, designate nft.wasm, and then upload the file. Once the upload is successfully done, the code ID will be created. This is just a simple ID, like a numbering from starting from 1 in ascending manner. So let's actually put it in as a variable. And now we need to initialize a contract. In this case, at the time of initialization, contract name and a symbol are going to be defined. Using the instantiate command and then execute. Once the initialization is done successfully, the contract address is generated. So same as a code ID, put it as a variable, just like we did for the NFT contract. So now you're ready for execution of NFT contract. Let's populate NFT. In this case, we're going to generate and create a parameter of name and URI, so that with the mint as a message, we designate the name and the URI. We use the execute command to execute it. We're successfully done. NFT token ID is generated and populated from the 0, any order. So when we try to check the query of the owner of the token that we just created, yes, we now can confirm that Alice is the owner of the NFT. So now it's all done up until the population of the NFT contract. So now we need to prepare ourselves for the contract, for the auction. Same as nft.wasm, we upload auction.wasm. The code ID for this contract is a 2, so we'll put it as a variable. Now we need to initialize auction contract. The message for the at the time of the instantiating the auction contract is something like this. In order to designate the auction duration at the block height, so we set the 100 block after listing. Let's initialize the auction contract. We put the auction contract address as a variable as well. Now we're going to begin the auction, but there's one more thing that we're going to do. In order to make sure that auction contract to transfer the NFT successfully, we call the approve for all of the NFT contract and give an authorization. So now everything done, we're ready. So let's start with listing. Here is the listing message on the screen. And it's the contract address and token ID, and also the minimum amount for the bidding. These are set as parameter and pass on to it. In this case, the initialized NFT contract we did first, and also the token ID as a 0. And we set the 100 stake as the initial bidding amount.
Let's execute this. And after the listing is successful, the listing token information can be acquired and listing ID is specified. Confirm the listing ID. The listing ID for this, the log shows this is a value and specify this value to be the listing ID. The listed token ID value is 0 and the contract issued NFT address and also the seller's address, the current maximum number of bids. This information can be confirmed. Also, this time, NFT owners confirmed, then auction contract address is shown. Next, finally, let's do a bidding. For bidding, just specify listing ID. That's all. The money used for bidding, the command amount flag, is set to specify the money used for bidding. This time, the minimum amount of bidding is 100 stake, so it is 1 over, and that is 101 stake. And then as from address, specify the row, and then execute the bot from the bot. The bidding is complete. Once again, let's confirm the listing token. You will be able to see the updated bidders information. The maximum bidding amount is 101 stake. The maximum bidder is Bob address. Next, final process is after the auction is complete, let's get the token out. Withdraw like bidding, just specify listing ID, that's all. The withdrawal is executed successfully. After withdrawing, let's confirm the token owner. Certainly, the result of the auction shows NFT ownership is transferred to Bob. This is the flow to execute the contract that was developed. The repository, which is in public, allows you to develop contract and can try out the execution of the contract, so please have a try. I'd like to summarize. With Line blockchain, the token can be issued and also sold and bought, and these are the basic transaction and also the business logic to be implemented on chain. We are going to release smart contract feature. As for the execution foundation, we are going to have the Cosm WASM for executing with message-driven format, but the smart contract has its without using proprietary language. The general programming language allows you to write. So even if you don't have the experience of developing smart contract, I think we have the environment where the users will feel comfortable to develop the smart contract. And if you want to call another contract, we have our proprietary developed dynamic link. You can use that as well. In this session, in the Line blockchain, I talked about the basic preparation for developing contract. And there are already publicly available samples, so please try it out. This concludes my session. Thank you for your attention.
Thank you, Mr. Takahashi. Now we would like to do the Plastoc session. So we would like to dig deeper in the topic of the session, with some questions from the interviewers. We would like to take as many questions as possible from the viewers. If you have a question, please use the question icon at the right bottom. You can drop a question from there. Our viewer is Shinichi Urakawa, Yahoo Japan. Please introduce yourself. I am Urakawa. I'm using Line Blockchain at the hackathon and other occasion. Tutorial is very rich, very user-friendly. And this time I introduced a smart contract. I've never executed or implemented before, but after listening to your session, the session itself really encouraged me to give it a try. So the business logic, it's now available on chain. So by doing so, what kind of benefit we can enjoy from the user perspective and developer's perspective? For user perspective, for example, even if they can publish the token with the NFT, was there some limitation or restriction on the business transaction? And if the business logic is not available on chain, the user never know what kind of transaction they could do. So that means that dependency on the developer or service provider side. But since the business logic is available on chain, because they cannot falsify the business logic, giving some certain level of the trust and confidence to the users. So what's the benefit from the developer's perspective? Yeah, for the developers, using a smart contract to develop and create something new. Well, nowadays, there are many applications available on the blockchain, but there is no service like Yahoo Japan's provide. So that kind of the new service is something that we can launch into the market quickly by taking advantage of the business logic. And whether the users really will receive it or not, yeah, that's probably another point to look into. So the things are on chain. So that means that you can secure transparency and openness of the logics and things. So the publicly available contract could be recyclable, but what about the interest and stakeholder of the contract? So for example, if the contract is publicly available as an OSS, and you should abide by the OSS stipulated license terms and conditions. So it's not really the legal topic, but it's more like you should actually follow the license stipulated on the OSS. So the license information is available on the common field of the contract? No. Within the repository of the code, and you can find it there. Thank you. And also the submessage and reply function that you touched upon. At a glance, the processing or computing the structure could be simpler, but correct me if I'm wrong, but what kind of issue you wanted to address in the first place to decide to use the submessaging? Not necessarily the submessaging features, but to call the other on a contract that featured in the function itself as the ERC20 used as a coin. And there are such coins already existing. And there are the applications as a standard, and in such case, the contract is called from the service side and then another contract is actually that kind of the feature is needed.
I understand. Thank you. I have another question. You can make business logic on-chain. My understanding so far is for the contract or for transaction. I understand the contracts are going to be on-chain, but other than that, if you can do business logic on-chain, are there any benefit that comes with it? Any example? Well, the trust, reliability is a key. It depends on how to design services. So not everything must be existing on-chain, but from the people who use services and also people who design services, if the business logic lies on chain, then it is more preferable according to some users. Therefore, it's one of the measures which is allowed by smart contract, but with it or without it, LBD, the Aligned Developers blockchain, will allow you to issue token easily. And if you just want to issue the token and if your needs are fulfilled according to your service development, you can use Line Developers blockchain. Thank you.